Hello everyone. Good morning all. This is Kanu Bhutani here, and today we will see uh, what, where, when, why the Pinecone database is used. So, what is Pinecone database? It is a managed vector database designed for similarity search. So, it is designed to, a database is designed so that only the similar words can be searched and retrieved in the AI ML applications. How it does, it stores high dimensional vector embeddings to enable fast and scalable semantic search. So it has the vector embeddings means it is the every word is given a vector recognition representation of that embedding, which is the number 1.123456789. Accordingly, based on these vector embeddings, it can enable the fast and scalable semantic search for similarity words. Where it is done, so the Pinecone runs on a cloud native service, mostly on AWS, or it can also be accessed through API from your AI applications that maybe you have seen my previous video how I have used the Pinecone API to connect to the API applications, typically which is hosted on cloud or on premise. So see my previous video on Pinecode, so you will come to know how the API is used. Why this is used, it solves the problem of finding semantically similar data. So in case if I put the text like music, so the similar data like, and then if I ask the question that what are songs? So music, song, lyrics, tune, all that it will save the similar data of the text and image and quickly and accurately, and traditional databases can't handle such a high dimensional vector comparisons that a Pinecone can. So in traditional databases, what we do, we enter the music separately, the tune, song, singing, so that are different rows it will occupy in traditional database. But here it will occupy the high dimensional vector comparisons like music. If it is 1.0, then the song will be 1.1, and the singing will be 1.2. So it will compare the high dimensional comparisons will be done, which will can be effectively handled by Pinecone. When to use Pinecone? Pinecone when you need real-time recommendations, you want to recommend something, semantic search, anomaly detection, or question answering. So once I enter the data, say Kanu likes music, he also enjoys singing song. So if I ask the question from the AI that what does Kanu like? So it will immediately give Kanu likes to sing. Is it's especially useful once you are converting the data into embeddings models like Hugging Face OpenAI. How it is used? You send the vector embedding to Pinecone via API and then query it with the other vectors to find nearest neighbors. So once if the question that I ask, the data which I feed in the vector, you send the vector embedding. The data which I feed in, for example, if I say Kanu likes music, so that embedding I will be doing in Pinecone API. And then when I query that, it will go to the other vectors which are nearest neighbors. So if I say Kanu likes music, so when the music is stored in Pinecone 1.0, so along with that, it will store singing 1.1, songs 1.2, tune 1.3. So everything will come in 1 point something something something. all the similar words. And then what it will do, it handles this indexing, storage, and retrieval without requiring infrastructure setup or manual tuning. Then, if you give the question, what does Kanu like? So it will immediately give music because that only I've entered. So it won't say that he likes software. Say, for example, if I put the entire text as Kanu likes music, he is a software engineer. So, what does Kanu like? If I ask the question, it will give music. And what Kanu does, so it will give software engineering. Who uses? It is used by AI developers, data scientists, enterprises needing scalable vectors, and it is developed by Pinecone Systems, a company founded by Yahoo researcher. So this is all what we can do in Pinecone. So I have listed down five important and different use cases that you can use. One is semantic search for e-commerce. So the problem is a user types running shoes for flat feet into the search bar, but traditional keyword search misses relevant products. Pinecone converts the user query into embedding and retrieves the semantically similar items. Personalized recommendation. A music app wants to recommend new songs based on what a user has liked before. So, representing each song as a vector will help us to get the similar tracks. Duplicate detection. So here in the large data sets, if the document management system users often upload similar or duplicate files, so it converts the document into embedding and uses Pinecone to find the similar entries. Real-time question answer. So a customer support bot needs to answer questions by referencing a large collection, and the Pinecone solution is embed all documents using an LLM, example OpenAI, and the top K relevant docs for Pinecone. The fifth one is anomaly detection in user behavior. So if there is a fraud detection system needs to spot unusual user activity compared to historical behavior, the Pinecone will store the typical user behavior patterns as vectors, then compare new activity vectors for similarity, and the low similarities can identify the required anomalies. So thank you very much.